Hi class, back again. Here is how to do paired differences. Now, what paired data is, as your manual should have talked about, is this is data that is closely linked. So before we were testing for differences in stuff that was quite different, right? Like, if we look at the other example, the question that I would have just done in the previous video, sorry, I'm just going to get to it. Looking at the dollar amount spent on meat products, the amount that men spend shouldn't affect the amount that women spend. Well, paired differences are a bit different. Here we're testing, well, it says some cereals claim to reduce cholesterol when part of a balanced diet. A group of 6 males with high cholesterol decided to test this by eating such a cereal over a period of 3 weeks. And here was their results. Okay, so, the two variables are your cholesterol before you started eating this balanced diet and then after you started eating it. Well, the individual data points greatly influence each other because everybody has a natural resting rate of having some amount of cholesterol built up, but it's going to vary by person to person. So when you're testing whether it had an effect, you don't really care if what the total cholesterol level is. You care about what the cholesterol looks like after you have the balanced diet. Now, this is what's called paired data. So when you're doing a question like this, you're going to have 2 columns with a bunch of data points, and it should be the same number of data points. And what you're going to have to make is a difference table on the side of it. In this way, because you're going to be trying to figure out what the difference between these values are. And I apologize that these don't line up perfectly with my pages, but you're just going to have to bear with me. So you're going to look at the difference between them. So here, the difference is 5. I'm just subtracting them. 244 minus 234, that's 10. 260 minus 255, that's 5. 232 minus 238, that's negative 4. And we can have negatives here. 246 minus 245, that's 1. And then 251 minus 247, that is 4. Okay? And now what you're actually going to do, it's actually pretty straightforward. You're just going to treat it like a regular problem. But so you're going to be using either this one or this one, depending on the size of the sample. Well, here the size of your sample is 6. So n equals 6. So this is a small sample. And we're going to use the t distribution. Okay? So let's just go through it. This one's pretty straightforward. The only real complicating factor is just you have to make that difference chart. But you do have to do what I did in the last question where we enter the data in and figure out the key values. So we need to know the average of this difference, and we need to know the standard deviation of this difference. So we're going to do the same thing I did before. We're going to enter each of these values. So 5, put it in the calculator. 10, I enter it into the calculator. 5, I put that one in as well. 4, and then you have to put a negative in front of it. Don't press the minus sign, just put that. This is how you switch from positive to negative. So it's negative, we put that into the calculator. We add, whoops, I'm going to try it again. 5, 10, 5, 4, 1, and then 4. So now I have 6 data points, and there's 6 data points there. So now to figure out the average, second function, this button right here, you can see that little X bar just above it. Okay, so it's 3.5. And you can see the sun's encroaching. This can make life really difficult for us, but we'll try to get through this. Maybe I'll do this. Put a little bit of shade on it. Okay, so 3.5 is here, and the standard deviation, second function, I press this sample standard deviation button, and I get 4.6. Let's do, because it says 6797, so let's round that to 68. Okay, so now we do the whole process again, the whole hypothesis test process. Null hypothesis. The null hypothesis is H naught, is that mu d, I'm going to put a little d there because it means difference, a little d, is equal to 0. right? Is we're saying that there's no difference. The thing we're trying to test is that it reduces your cholesterol. So mu D is 0. Now H1, 2. Now remember, the difference is we tested the cholesterol before and the cholesterol after. Well, if this difference is cholesterol before minus cholesterol after, and we're trying to see if there was a decrease from before to after. So if we went before minus after, if there were a decrease, it would be a positive number. It would be bigger than 0 because again, we went before minus after. So if we were looking for a difference, before should be bigger than after because we should have reduced the cholesterol. 3, we need to figure out our test statistic. No, a rejection region, pardon me. We know that it's a small sample. We're using a t-distribution. We know that mu d is greater than 0 and mu d is greater than 0. It's going to be, the rejection region is going to live up here somewhere. So we need to find our T alpha, and it's and again it's a one-tailed because this is greater than or less than. And we need to figure out our degrees of freedom. Now, because even though this is a difference, these things are so connected to each other that we're kind of treating it like the original problem. So the degrees of freedom in these are n minus 1. So n is 6, so this is 5. Let's get my sheet out, and we can figure that out. Our t-distribution is 5 and 0.05. Right? We said we're going to use 0.05. 5.05. I get 2.015. So T alpha equals 2.015. Okay. Next step. What is the next step? Oh yeah, 4. We need to figure out our test statistic. In this case, oops, hit my microphone there. Sorry about that. So in this case, T is D minus the difference over SD over N. So what's going on here is we get T equals D bar, which is this one up here, minus the difference, which actually ends up being equal to 0, divided by S over square root of N. So D bar is 3.5 minus 0 because, of course, the difference we're looking for, we wanted to see if there's any difference at all. So D has to be 0 over, now S is 4.68 divided by the square root of 6. So let's figure that all out. We have 4.68. So 4.68 divided by 6 square root equals 1.911. So this is equal to 3.5 divided by 1.911. This can be a close one, actually. So 3.5 divided by 1.911, we get 1.831. So where's that going to live? It's actually going to be, if this is equal to 2.015, then this one right here, this is going to be our 1.831. So what we say, well, it's not in the rejection region. So 5, we fail to reject the null hypothesis. And 6, so there is insufficient evidence to conclude that a balanced diet reduces your cholesterol. Now that's just in this test, okay? And again, we know in reality that balanced diet probably does reduce your cholesterol. And some of the results seem to show that, some don't. So the thing is, probably what happened is we didn't take a large enough sample size to say anything conclusively. So From how I can see it, I think it's really just a matter of the way the data is set up. So, but as far as the math goes, the math is telling us that there's not enough evidence. Now, it's saying maybe go out and collect more evidence, but right now there's insufficient evidence. So again, just like the last question that we did for differences, this is sort of the template when you fail to reject. When you fail to reject, then you say there's insufficient evidence to conclude that whatever you want to test. That's it for paired differences. For those of you in Stat 202, you should have enough to do assignment 4 by now. So good luck and take care, everyone.